Hello everyone, I'm Liu Daizong, the first author of this BMVC paper, Rethinking Graph Neural Networks for Unsupervised Video Object Segmentation. I'm a PhD student from Wangshuai Institute of Computer Technology, Peking University. First of all, what is the unsupervised video object segmentation? This is a video-based task which we input the model a video without any annotation and require the model to output a segmented mask result of each object among the video. Existing deep learning frameworks of unsupervised video object segmentation can be grouped into two categories. The first is the two-stream networks. This class of method views both appearance and motion information via optical flows, which may fail to correctly infer the foreground when the object is occluded or nearly static. The second is the appearance matching networks. This method explores the correlation between two frames by sampling the similarity between their pixelwise embeddings without motion context. Since they all adopt Siamese networks to match the current frame only with the first frame, they cannot handle the appearance changing problem in long videos. To avoid the above drawbacks, the attentive graph neural networks was proposed to address unsupervised video object segmentation in a pure appearance matching manner without using optical flows like two-stream networks. Compared to other appearance matching networks, this graph-based network does not deploy Siamese networks to narrow the limited relation between two frames. Instead, it handles multiple frames at the same time, which alleviates the problem of appearance drift in long videos. However, this GNN-based framework attempts to eliminate shortcomings in previous frameworks. The performance of it is still limited to that of other models thus far. Therefore, in this paper, we argue that the main reason comes from the limited horticulture in the following two aspects. The first is the node design. Each video contains complex and diverse scenes. Each frame may contain visually similar objects in the background. Thus, to distinguish the foreground and background object is crucial to track the target object well. However, the extended node design of the global graph takes the whole frame as input and results in mismatching to similar objects in the background regions. The target object generally appears only in a small region of each frame. Therefore, instead of matching features of the whole frame, as in AGNN, matching the regions that only contain target objects is able to reduce useless computation and produce more fine-grained results. The second part is the global graph matching. To determine the foreground object, there are two essential properties distinguishable in an individual frame and the frequent appearance throughout the video sequence. However, the global graph-based network only focuses on finding the most frequently appearing object among frames, but fails to explore the silent information in individual frames. Secondly, since frame-wise global matching involves more to locate a possible area of the target object but suffers from the ambiguity of boundary pixels, it is important to capture more local details in individual frames for refining the mask boundary of the foreground objects. To this end, in this paper, we propose a novel framework called RGBL, which deleted node design and local graph refinement for local global representation learning by rethinking and addressing the limitation of the existing graph-based network models. For the node design, RGBL extracts regional features of each frame as the node input so that to filter out the background noise. In particular, we first develop a foreground localization branch to detect the region of the most silent object in each frame, and then obtain corresponding regional features by developing a regional attention to the feature of the entire frame. In this manner, our model not only locates possible region of the target object better, but also eliminates mismatching to similar objects in the background. For the global graph matching, RGBL narrows boundary-aware local saliency in each frame. Specifically, we first extract the object boundary by developing a boundary prediction approach on the extracted regional features and then introduce a graph-based boundary attention to emphasize on the local features of boundary pixels during the pixel-wise feature matching, thus enforcing accurate segmentation along the object boundary. This is the overall pipeline of our proposed method. You can find that compared to the original GNN-based framework, we additionally proposed the foreground localization and the local context learning modules. This is the details of our foreground localization module. This is the details of our local context learning module. This is our quantitative comparison on 3 widely used datasets. This is our ablation study. This is our qualitative results. You can find that our model segment the foreground object very well. Besides, our local localization module is very effective. That's all. Thank you. If you have any questions, you can email me.